Welcome to N is for Networking, the short, sharp podcast where we explain the jargon, acronyms, and concepts of the networking industry in plain language. I'm your co-host, Ethan Banks, a grumpy old network engineer who's been pushing packets around since the 90s. And with me is co-host Holly Metlitsky, a university grad with a master's degree working in the networking industry, but still somewhat new to the scene. In this episode of N is for Networking, we are going to discuss another question from my friend Douglas, who sent in a whole list of questions for us. Douglas did. Douglas is a college student right now, and he asks, what are VLANs and how do they help manage network traffic? What are VLANs and how do they help manage network traffic, Holly? Do you have an impression of VLANs, Holly?
Yeah, I mean, when it comes to VLANs, I immediately think of segmenting your network. That's really where they come up for me in the workplace, mostly for big organizations who are trying to, separate HR from finance, for example, and they are directing or segmenting their broadcast domains into smaller subsets using VLANs. Yeah, that's kind of my initial thoughts before diving into it.
Segmentation, keyword there, segment the network. And then you said broadcast domains. We're going to have to dive into that too. And actually, I know we're going to, I peeked at the show notes. I even wrote some of them. And I know we're going to talk about broadcast domains in some depth here. So first up, Holly, are VLANs happening at layer 2 frames or layer 3 packets?
Layer 2 frames for sure.
Yeah, exactly.
Mostly.
So VLAN is virtual LAN, virtual local area network. And in this case, we're talking about Ethernets. It's an Ethernet virtual LAN. So some history here, Holly, that this would predate you. A local area network Ethernet would have been a collection of Ethernet hubs, or even not a hub, but a wire. Just a physical wire that you would tap into. They had a tool called the vampire tap, and you would screw in the vampire tap from your workstation into the backbone wire and make an electrical contact to create an electrical bus. And an Ethernet hub, which would look much more familiar. It's a thing with ports on the front. You plug a cable into it. It was the same thing, basically, architecturally. It's just a dumb electrical repeater. And that would be a LAN, a local area network. Everybody was plugged into this common wire, this common bus, and saw all the traffic that was going to everyone else. That was a LAN, a local area network, a segment, if you will. Well, virtual LANs come about in the era of switching, and we haven't talked about the difference between hubs and switches yet on this show. Maybe that's a show for another day too, because we already got too much material for today, Holly. But virtual LANs allow us to take that concept of a segment and house multiple segments in one physical switch. Or spread a segment across multiple switches, but still have a contiguous VLAN, even though there can be multiple VLANs there. And that is done with a tag, Holly. Do you happen to know much about VLAN tags?
Yeah, I mean, when it comes to VLAN tags, I know, the range of numbers that you can choose from, 1 to 4094. Which I think starts to pose its own issues when you're working with huge organizations that are international and so forth, because even though it seems initially like a big number, which I thought when learning it, they very quickly get used up if you're using a lot of VLANs. So
yeah. So that VLAN tag, exactly what you said, it's a VLAN. That VLAN number is made up of 12 bits. Those 12 bits are part of a larger tag called a .1Q tag, as in 802.1Q, the 802.1Q being a standard that was issued by the IEEE, right? Right. I didn't look that up. Yes, that's an IEEE standard. Yeah, they're the guys that
it is.
They're the folks that do all the Ethernet standards. And this 32-bit .1Q tag contains several different bits of information, but 12 of those bits are for the VLAN tag. And right, you could have, if you did the math, knowing 12 bits, you did the binary and go, wait a minute, that's 4096 values. So how come we only have VLAN tags 1 through 4094? 0 on the bottom end and 4095 on the top end are reserved for whatever they're reserved for. And we only have those 4,094 VLAN tag IDs available to us that we can identify in that .1Q tag. But where does that tag live, Holly? Like, how would I see it? Where is it?
Well, I don't want to start conflating packets and frames, but I really want to say packet, but I'm not going to say packet. In the frame, it's a frame header.
Yes, it is part of the Ethernet frame. That is right. That is where you are going to find that tag. It's not in the packet. You could find other interesting tags in an IP packet, things like the table of service byte. You might interpret that as a tag. Depending on what you're using it for. That's, again, topic for another day. But right, the .1Q tag is part of the Ethernet frame. Exactly right. Okay, I got another VLAN question for you, Holly, then. So let's say we got a switch and we haven't created any VLANs ourselves. Do you happen to know if there is a default VLAN?
So there is. It's usually VLAN 1. As far as I'm aware. I think it's across all vendors, it's VLAN 1. What actually I'd like to bring up a little bit here, and I know we short on time, we got to get through this, but the difference between, we don't call it a default VLAN, we love to call it a native VLAN at Juniper. And I think that's really because I guess we give our customers the option to change it from one. From my understanding, that's kind of the terminology between default and native.
So in Cisco land, you can also have, now you got me thinking. I believe you can have a native VLANs as well. Oh, now you got me thinking, Holly. It's been a while since I set this up, but yeah, you can have a native VLAN as well. So, but you bring up, let's back up a second. There are terms that some vendors use around this technology, whether it's VLANs or really any networking technology, that means the same thing, but we're using different words. So let's stick with VLAN tech for a minute here. A concept we haven't quite talked about yet, but we're going to get to, is the concept of a tagged port, or in Cisco parlance, a trunk port. They mean the same thing. It means that line can carry tagged frames across it, and it's not a member of a specific VLAN. It's a member of no VLAN or all VLANs, depending on how you look at it, or it's a member of all the VLANs you allow to traverse it, since you can define which VLANs can be allowed across a given port if you want. But again, tag port versus trunk port all depends on the vendor, but means the same thing.
Yeah, I had to double check on that because I'm a trunk port, access port. That's my world. So when I'm like, wait, tag, that seems the same thing, but why is there a different word for it?
And it is. It is. Yeah. So to go back to the default VLAN question, typically default VLAN means you didn't configure one, there's nothing there, so every port is going to be a member of VLAN 1. Nothing's going to have a tag on it by default. You don't put a tag on a frame unless you are sending it across a shared link, that tagged or trunked port, and you need to identify that frame as being part of a VLAN. So a default VLAN, again, typically VLAN 1. I can't think of a vendor that isn't using VLAN 1 as a default. That is typical. I think there are exceptions, because there's always exceptions and caveats and weird little corner cases in the networking world. And by default, all ports are going to be a member of that default VLAN. So if you take a switch out of the box and don't configure it at all, you just plug it in, plug hosts into it. Will they be able to communicate? Yes. They're all going to be part of the default VLAN. That all ports on that switch are going to be members of that default VLAN. The thing's just going to work. Even though there's actually VLANs in there and tagging is possible, and you could have multiple segments in multiple VLANs. So Holly, the next thing I wanted to walk us through, what happens when two Ethernet hosts that are connected to the same VLAN and using IPv4 want to talk to each other? And we could say that the sender is, let's see, it's 10.0.0.100, the receiver 10.0.0.200. And we'll just call them .100 for the sender and .200 for the receiver as we go forward. So what I'm getting at, Holly, and is IP addresses know each other, but to send that IP packet across the Ethernet wire, what do we have to do with that packet? We got to wrap it in a frame, right?
Yeah. Yeah. So now the IP knows of each other, but they don't know about the frames.
They don't know about the frames. They don't know how to use the physical wire that they're plugged into, or wireless is very similar in what happens here, but they don't know how to actually take this packet and electrically encode it in such a way that it can go on the wire and get delivered to somebody else that's on that wire. So we've got to figure out who's the Ethernet recipient that I need to send this thing to. You know your own Ethernet address, but I don't know, like Holly, I don't know your Ethernet address if we were on the same network. How would we, but we might know each other's, like I know I'm .100 trying to send to .200, but the transport I got to use is this Ethernet thing. So I got to figure out the frame. So this is the process that we want to discuss.
You've got to ask. Someone's got to tell you. Someone's got to tell you what your Ethernet address is.
And what's that process of asking?
So that's ARP, or Address Resolution Protocol.
And the question is going to show up if you were to put a packet sniffer on the wire, like Wireshark, and just have it run and say, show me all the ARP packets. You'll see ARP, Address Resolution Protocol packets. Ha! Frames. Well, it's a packet too. But yeah, we're going to see those on the wire. And so .100, our sender, would put an ARP request on the wire, broadcasting to all Ethernet devices into the VLAN. Is anybody out there .200? Hey, I need to send an Ethernet frame to you. Are you .200? If you're, let me know who you are so I know how to address this Ethernet frame to you. It's a broadcast, so everybody that's in that VLAN is going to see that broadcast frame, and .200 is going to reply back to .100 with a unicast, just as in directly, not broadcast, but just send it. I'm .200. Here's my MAC address. We talked about MAC addresses in frames versus packets. That was our last episode 2. So now .100 knows the MAC address of .200. It can put the destination MAC into the Ethernet frame. It can put the packet into the frame and put the frame on the wire, and now it's going to get delivered. Does that sound right, Holly?
Yeah, sounds right. I mean, you got to know where you're sending it to and what the address is, MAC address or just address in general, if you don't want to, stick to networking terminology.
Now, another little interesting detail is .100 is going to store the information, the answer it got back from 200, in its ARP, Address Resolution Protocol cache for future use, so that it doesn't have to put another broadcast ARP on the wire every time it wants to talk to 200. It's going to cache that answer. And in fact, on most desktops, desktop systems, your Windows computer, your Macs, your Linux boxes, there's a way to see your ARP cache. I know on Mac, it's you can just do ARP-A, and it will tell you, here's all the ARP, Address Resolution Protocol entries that I know about. And they have a timeout. They'll expire eventually because, things change. You can't have that answer forever. So why do we go through all that, Holly? And the answer is goes back to your concept of a broadcast domain. The broadcast is the key part of what we happened here to kind of help us understand VLANs and segmentation. Every host connected to that Ethernet VLAN saw that broadcast frame. That is our broadcast domain. So let's say we had a switch with VLAN 1 and a VLAN 2. If I'm in VLAN 1 and I send a broadcast out, does anybody in VLAN 2 see that broadcast?
No, it shouldn't.
No, it shouldn't. In fact, if it does, you miscabled something or something's gone wrong for sure. Yeah, no, it shouldn't, because that's part of what the segmentation is all about. You've created, with a separate VLAN, a separate broadcast domain. So if you're trying to control what Ethernet devices can find each other via broadcast, or you want to limit which hosts can talk to one another, you can create VLANs and put different hosts that you want to separate communications from into different VLANs. And then you can put rules in place saying who can talk to whom across those different VLANs. There's a little more to the story in that, because I'm kind of implying, Holly, that if you're in the same VLAN, you guys can talk no matter what. And and that's not actually
quite
true.
Always the case.
No, it isn't. There are other things we can do to prevent hosts that are in the same VLAN from talking to each other. But fundamentally, hosts within a VLAN can talk to each other. Although, although part of the world that you're in, I suppose, is about, and modern networking is about controlling which hosts can talk to one another, even if they are in the same VLAN.
Yeah.
Zero trust gets into this concept, and well, again, we got to get through this podcast, Holly. There's all these little rabbit trails we could go down. So here's a question for you, Holly. See what you remember from your studies. How do we make switch ports a member of a VLAN?
So I guess immediately I'm thinking, okay, what command am I using to assign that switch, like assign the VLAN to the switchboard? But you got to first define, is that port what we discussed earlier, access or trunk? So if we want multiple VLANs on that port, we've got to assign it as a trunk port and then assign those VLANs to that port.
And if we just want a switch port to be a member of a single VLAN, that would be an access port.
Yep.
And access as in, I have a workstation that needs to access the network. It's an access port. I'm going to plug it in, and that switch port is a member of that VLAN. Now, the big difference between an access port and what you call a trunk port, other network vendors will call it a tagged port, is whether or not you actually have that .1Q tag with the VLAN 12-bit identifier inside of it or not. On an access port, no, there's no reason to have the tag there. If that frame needs to traverse a trunk port, when it does traverse the trunk port, the switch is going to put the tag on there. That .1Q tag will be on there. It'll be a tagged port, therefore, or a trunk port. Again, just depending on the vendor. Another question, well, actually, let me back up a step here. How do packets, or frames in separate VLANs talk to each other? Have you run into this, Holly? Actually, I know you've run into this. Yeah.
Yeah, I have. And I was actually working on it the other day, and it's quite funny because it's almost, you just do it. Like, I knew what I was doing, and then I had to take a step back to think about it, to explain it to somebody else. I'm like, well, they don't. I'm like they don't. If they're in different VLANs, they shouldn't speak to each other. Right. So you've got to do something to allow them to communicate. Yep. And that's where your routers come in. Now, we can dive into that a little bit, but they shouldn't speak to each other. So you've got to do something to allow them to communicate.
And for today, that's as far as we need to go. You need a router. You need a router in the middle that's gonna take care of that. It would be, because you're right, VLAN 1 and VLAN 2, separate broadcast domains. They've got no path to one another. So how do you get traffic between these VLANs to speak? You use a router. Now, that could be, and most modern layer, you'd call it a layer 3 switch, is modern switches are also routers. They have the ability to do this. So if VLAN 1 needs to talk to VLAN 2, some host in VLAN 1 needs to talk to a host in VLAN 2, the frame is going to be recognized by the switch. The switch will have the default gateway for that VLAN on it, and it will have the ability to go, okay, so this packet in VLAN 1 needs to talk to a host in VLAN 2. I will route it. I will take the frame, decapsulate that frame to the packet, route the packet into the VLAN it needs to go to, make it a frame again, re-encapsulate it as a frame, and deliver it to the host on the other side. That can all happen in a switch. It can happen among separate switches. And that's another thing to consider, is that you can have all this functionality, again, in a single device or spread out across a ton of devices, dozens, hundreds of switches, potentially. You don't want a huge network like that without having a bunch of layer 3 separation. In fact, how to scale a network is again yet another conversation, Holly.
Yeah.
But you could have, here's a switch that's got VLAN 1, and the default gateway for VLAN 1 could be in a different switch down the line somewhere. Have that switch down the line do the routing into VLAN 2, and the host in VLAN 2 is 3 switches away, and all the switches in between are interconnected along VLAN 2. It could work. It could work like that. All right. So now, Holly, let's bring this thing home here with just a couple of closing questions. Is it possible to control which hosts can talk to each other within a VLAN? Because by default, no, but we do have a few tools. I don't know if you've used any of these.
I haven't configured them myself, but I have dealt with usually customers who have this configured already, and now we're trying to implement that in a different way. So, certain access lists is usually what I've run into.
Yep. And there's a variety of different access list tools, and different switching vendors and different switch platforms will have different access list capabilities. Very simple switches may not give you much of any sort of access list, but any name brand switch, if you will, Juniper, Cisco, Arista, you're going to have some kind of access list functionality. And then there are different styles of access lists. And it can get confusing, actually, looking at a switch configuration, because you might have, for example, a port access list. That is an access list literally on a port, on the switch port, governing traffic that is coming typically in the direction of into, not out of, but into the switch port. So traffic coming from a host into the port, there's an access list that is filtering that traffic. You also can have VLAN access lists depending on the switch, which can govern traffic in between hosts in the VLAN, and maybe hosts going out of the VLAN, depending on the switch, depending on the vendor, depending on how it was implemented. There's yet another tool, and this is a crazy one, Holly, private VLANs. You want to have some fun, get your mind blown a little bit? Go look at private VLANs.
I haven't actually heard. Yeah. So that's a new one to me.
I don't know if they live much these days. I mean, back in the day, I had some use cases for private VLANs, and you can make ports. You can make different hosts in the VLAN be able to talk to each other or be completely isolated, and you define the character of each port that's in the private VLAN a specific way. Like you're a host in my private VLAN. I forget all the nomenclature, but you're a host basically, and you can't talk to any other host. You can only talk to the router port, and you can have a port that's basically everybody can talk to this port because it's the port with the router on it. So I don't want, and the use case is I don't want anybody on my private VLAN to be able to talk to anybody else on this private VLAN, because they shouldn't be able to see each other. So a use case for that would be, I've got a bunch of clients of mine that all need to connect to my network, and they connect to my network, but I don't need them to connect to each other. I only need them to connect to me. So I land them on a private VLAN and make sure the private VLAN is configured so that they can't talk to each other, but only to the router port that connects them to whatever the assets are that I'm giving them access to. So private VLANs, I almost never saw those implemented. I only had ever one use case for it in all my years of doing networking stuff. And then port access lists and VLAN access lists. I will say it's not a solution I love if you're going to do them manually, because it just gets so hard to maintain these kind of things and track them. But if I'm using a higher level security system that happens to implement the security by using port access lists, and I don't care, at that point, it's up to the security platform to take care of that for me. Great. Oh, works great. Now, so same question, Holly, but just a little different. So that was, if by default hosts can talk to each other within a VLAN, but maybe we don't want them to, what are some tools? Now, what are our tools if we want to control which hosts can talk to each other in separate VLANs? And this is much more common, I think.
Yeah. I mean, I guess that's access lists, not VLAN. I mean, could be VLAN access list still, but inter-VLAN access lists, not intra-VLAN access lists, or firewalls. If you're using a security router to do that routing between your VLANs.
Yeah, exactly. So access lists, very common use case here, where you'd apply them rather than at a switching level, like a port access list or a private VLAN or a VLAN access list. You're just using a more, I would say, a traditional access list, and you're applying that at the routing level where you're filtering packets. Because when you're doing inter-VLAN filtering, you're thinking about IP packets. And remember from our last conversation, it's not like a frame can only have an IP packet in it. That just happens to be what we see in modern networking. You could put a whole bunch of different things in there. But for our purposes, yeah, you're talking about an IP access list. It could filter who's talking to whom in separate VLANs. I would use those in isolated cases, on a router, specific use cases where it's like, yeah, that's the best fit. I would prefer to use firewalls for most of that kind of thing. So like in Juniper land, that would be an SRX.
Yeah.
I'd rather have that firewall, which is a special device that's very good at managing, maintaining those things, usually has special capabilities, special UIs, maybe that help with governing those access lists, do that work. But you don't always have a firewall in between VLANs, right? Often we do, but not always. There's lots of ways to control traffic going in between VLANs. And again, in modern networking, it's increasingly common to have some sort of controls in place, and the different vendors implement their security solutions in different ways. All right, last question, Holly. And I think you might know this one because I know this is one of the areas you work in as in your work for Juniper. In a VXLAN fabric, VLANs fit into the scheme somehow. What do you know what goes on there?
Yeah. So, I mean, going back to what I commented on earlier about the number or the limitations of the VLAN quantity, when it gets to VXLAN, you're going to very quickly run out of VLANs. So they then get mapped to VNIs, so virtual network identifiers, to transport them across the fabric. So it really is a numbers game. You taking away your VLAN tag and now replacing with a VNI tag. Do you need to do that? Well, you're going to run out of VLANs very quickly, so you need that VNI.
Yeah, if you're a bigger shop, for sure. Yeah, the VNI. How many VNIs are there? 16 million, right? Is that the max number? I forget. Yeah.
Something around there.
So, right. So VXLAN as a fabric, right, with the virtual network identifiers, it replaces that concept of a VLAN, if you will, with VNIs. And exactly right. We go from having just over 4,000 VLANs to 16 million virtual network identifiers. And when you hand off an Ethernet frame into the VXLAN fabric, you are actually encapsulating that entire Ethernet frame in the VXLAN packet. And that VXLAN packet's going to have that VNI assigned. And it's the common way to deal with this to map the VLAN it's coming from into a VNI for transport across the VXLAN fabric. It'll get decapsulated on the other end, and a VLAN identifier will be put back onto the frame if necessary, if we need it to be tagged, or just have it put into the correct port. And you don't have to have contiguous VLANs on either end, as I understand. You can get kind of crazy with your mappings. There's use cases where you might want it to be mismatched. You're nodding your head, Holly.
Yeah, it gets quite complex very quickly.
Yeah.
It took me quite a while to wrap my head around this, starting from VLANs, and now suddenly I'm like, oh, I don't need that, and I've got 16 million of these VNIs. I'm like, okay, let's back up.
So quick review for all of this. VLANs are segments. Broadcast domains would be the way to think about them. We're controlling who can see whom by limiting the broadcast domain scope. VLANs are happening at layer 2. And if we're moving in a switch with multiple VLANs, you're going to have a tag involved, an 802.1q tag that includes a 12-bit value. That is that VLAN tag number. Now, we talked about a lot of other stuff. We talked about, filtering. We talked about mapping to a VXLAN fabric at the end. Some of that was bonus material. If you have any takeaway from this, dear listener, it's just to keep in mind that virtual LAN is about that segment and keeping network traffic segmented one from another. It's a security boundary in some regard, and/or you could use it for performance and for scaling as well. That's less of a concern than it used to be, but we were very concerned about how many hosts were in a broadcast domain because you get too much broadcast traffic out there and it slows everybody down. That's less of a concern these days, but that was a big thing way back in the day that we used to design around. So, all right, Holly, how can people follow you on the internet?
You can find me on LinkedIn. Just search my name, Holly Mitlitsky.
Excellent. I'm Ethan Banks. You can find me on LinkedIn. My other podcasts are Heavy Networking and Tech Bites, which you can find on the Packet Pushers podcast network at packetpushers.net. And there's also the Packet Pushers community Slack. Holly and I hang around in the Packet Pushers community Slack. And there is an N is for Networking pod channel. If you'd like to ask us some questions or request topics for us to cover in a future episode, we'd love to hear from you. And thank you for listening to N is for Networking today. So subscribe if you would, tell your friends. And hey, this is a new podcast. Would you leave a rating on Apple Podcasts? That's going to help other people discover the show. Many of you that have heard about the show are really excited about it, said you were telling your friends, really looking forward to it, and so on. So leave that rating, and it's going to help other people you don't even know discover the show. You will find N is for Networking anywhere that you get your podcasts. Another way you can tell us about topics you want us to cover, packetpushers.net/follow-up, and we will add whatever your request is to the list. I've been doing that all week long. Just remember, networking isn't hard. Other people figured it out, so you can too.